All right, so a video here that puts together the different types of fatty acids, just refreshing the videos that we've already had on structure specifically of fatty acids, structures and thus function of triglycerides that are made from both saturated and unsaturated fatty acids. And so now we're really going to see some of the more applicable sort of ways to think about fatty acids. So nice infographic here that puts these pieces of information together. So we're going to sort of talk about these four quadrants sort of individually, separately, talk about how they're connected and so forth. So the first thing that I want to do is just kind of distinguish and highlight where these come from. So specifically, when we talk about saturated fats, we tend to think about saturated fats having sort of an animal source. And if we read here just what they say, again, saturated fats have no double bonds. They're solids at room temperature. In our last video, we talked about why that is. Increased intermolecular forces, increased melting point that makes them solids at room temperature. We'll talk a little bit about sort of their heart health implications more next semester when we talk about their metabolism. But because of this, we'll highlight that saturated fats have kind of gotten a bad rap because of their impact on LDL cholesterol levels. But when we have our videos on cholesterol, I'll hope to convince you that just looking at each one of these things individually is really not the totality of the picture of cardiovascular health. Again, it indicates here they've previously been associated with heart disease, although more recent studies and reviews have called this association into question. So we'll talk about some specifics of that. So again, saturated fats tend to be of animal origin. When we think about unsaturated fats, again, coming as both monounsaturated fats and then polyunsaturated fats, these largely are plant in origin. And this is going to have some implications when we talk about sort of where we get these commercially and so forth. So monounsaturated fats, again, zooming in here and talking a little bit about monounsaturated fats, right? Just a single double bond. Tend to be liquids at room temperature, right? That kink decreases intermolecular forces and allows for a lower melting point so that they can be liquids at room temperature, but tend to solidify when chilled. So a classic example of an oil that we see that's a monounsaturated fat is going to be olive oil. Maybe you've noticed if you've made salad dressing with olive oil, you don't want to put it in your fridge because it's going to solidify, okay? Has a melting point that's lowered, okay, but not so much lower that it's always going to be liquid. Reduce levels of LDL in the bloodstream, thereby decreasing the HDL to LDL ratio. We'll talk more about that when we think about metabolism of fatty acids later on. So again, monounsaturated fats, sort of a hallmark that we have is olive oil. Coming over here to polyunsaturated fats, hopefully you'll recognize this. You'll see that this is an omega-6 fatty acid. Okay. These, again, are some of our seed oils. So we're going to see these as canola oils and so forth. When we talk about our omega-3s, we're going to see those in our fatty fish like salmon and so forth. Again, containing 2 or more carbon double bonds, liquids at room temperature, but again, they can start to solidify when chilled. We've got omega-3 and omega-6 fatty acids. Again, do have some heart health sort of implications, and we've learned about, and we'll see in our next video that we'll have the differences between omega-3 and omega-6 when it comes to pro-inflammatory versus anti-inflammatory behaviors. So those kind of connect with the types of fatty acids that we sort of saw in our previous slides here, right? Here we're going to have a saturated fatty acid. We've got a monounsaturated, polyunsaturated omega-6, polyunsaturated omega-3. Now, the last quadrant here, and I'm going to highlight this with sort of a gray because these being trans fats in general are fats that we want to avoid. Now, while in theory, we do have naturally occurring trans fats, and we'll see that when we kind of zoom in here and talk about the details of where we find these, this trans configuration tends to not be something that's found in naturally occurring fats. Remember, we have a cis double bond in naturally occurring fats. Okay, generally these are formed artificially. That's kind of why we're trying to avoid these. Process that we'll talk about in just a minute is called hydrogenation. They do have some naturally occurring sources. Some meat and dairy products will have some trans fats, but very, very minimal amounts. Again, we'll talk about the heart health implications next semester on this. Okay, many countries phasing them out. We'll talk a little bit just about the history of sort of what we see on food labeling in terms of trans fats. So that's just kind of an introduction of the things that we're going to delve a little bit deeper into on this slide. So first thing I want to do, I want to go back to this quadrant up here, talk about saturated fats, highlighting that saturated fats really get a bad rap. So get a bad rap. I hope something that I have said early and often and will continue to say, when there's things that your body can produce, I don't want you to think of those as being bad, right? Your body produces saturated fats. Saturated fats aren't bad. What makes things bad is often the bodily environment that we find ourselves in. One of the things we'll spend a lot of time talking about is inflammation and how inflamed your body is, right? Highlighting that acute inflammation is not problematic, right? Acute inflammation is good because whether it's healing from a sports injury because that inflammation increases blood flow, or you've got a cut that got infected and now we've got the ability for inflammation to bring sort of healing molecules there. Acute inflammation is not problematic. What is problematic is chronic inflammation. Here's one of the biggest culprits for chronic inflammation: chronically high blood sugar levels. Okay, those are going to be really problematic. So we'll continue sort of talking about this and delving deeper as we go through the semester. But saturated fats really get a bad rap. But here's why there's a lot of benefits for thinking about saturated fats, particularly in the food industry. There's a lot of palatability. We've talked about this already. If you just take, lard or Crisco or, any type of a saturated fat as is, pretty much flavorless, okay? But saturated fats often are a vehicle for flavor molecules. So a vehicle for flavor molecules, right? If you think about bacon grease, and I know nobody eats bacon grease, but why bacon and bacon grease and things like that are so flavorful is not because of the fat, but it's the flavor molecules that are often hydrophobic compounds that like to associate with the fat. So again, fat can be a great way to have palatability. One of the stories we talked about in class was highlighting that in the 1980s, when they tried to make diets more healthy for people, they thought saturated fat and fat in general was bad. So, hey, if we make everything fat-free, it's going to be healthier for us. Well, unfortunately, it made things pretty unpalatable in terms of flavor. So what did they add in excessive amounts to increase palatability? Sugar. Okay, so the thought was, hey, it's fine if it's fat-free and it's, 200 grams of carbs. That's not a problem because it's fat-free. Well, now we know how problematic sugars can be to our overall metabolic health. And in particular, when we talk about triglyceride levels, right, we'll do a deep dive into blood work. And we talk about getting your blood triglyceride levels, even though that's a lipid that's in your body, it really in high levels is reflective of carbohydrate dysregulation. So again, we'll get into those details later in the course. So palatability is one of the perks and the benefits of saturated fats. Another perk and benefit is that there is an increased shelf life, right? So if we look at sort of the functionality that we have within a saturated fat molecule, right, particularly if this carboxylic acid is part of an ester linkage as we find it as a triglyceride, right? If you think back to your organic chemistry and you think about the chapter, the learning unit that was on alkanes, really not a lot that happened with alkanes. Alkanes didn't have a lot of chemistry that happened with them, and that's because they are largely unreactive, and that's what contributes to this increased shelf life. Now, downside, a problem that we have, a negative that you have for saturated fats, is they are quite expensive. Now, if we think about this sort of from the food chain standpoint, and we're talking about sort of needing to have saturated fats to use as a fat in a food product, since you're going to be taking them from an animal source. Not only is it not really renewable in the way that plants are renewable, you just plant more, right? You have to grow a whole other animal, right? That's not necessarily an advantage. So they're pretty expensive, all right? So along comes chemistry to sort of help fix the problem, right? We know we've got lots of plants around. We have lots of ability to sort of grow more plants. And plants in particular, a huge advantage for plants is that they are very inexpensive to produce, right? So that's a huge perk of plants. Well, but here's part of the problem, right? So plants having mono or polyunsaturated fats, right? Oils at room temperature. Like nobody wants to have a potato chip or a candy bar that's got liquid fats in it, right? Ideally, you want something that, like the M&Ms say, it is melt in your mouth, not in your hands. So when it's at room temperature, you want it to be a solid, but as soon as it hits your mouth and that, 98.6 degrees, you'd like it to melt and have that more fluid consistency, right? So maintaining that important melting point is important, right? You don't want to take a bite of a candy bar and be chewing on it and still feel like it's waxy in your mouth, right? That's not palatable. So along comes chemistry and it says, you know what? Let's take these inexpensive plant oils and let's do some chemistry. So here's the chemistry that happens. I'm going to move down here next to our polyunsaturated fats to sort of talk about what we do here. What we do is we take an unsaturated fat that's inexpensive but has double bonds. And by reacting with hydrogen, we do chemistry that's called hydrogenation. And we convert this unsaturated fat into a saturated fat. So again, this is hydrogenation. Okay. Now, the problem is you don't want to do this too much, right? Because if you blow away all of the double bonds and make all of these fats saturated fats, you're really going to have too high of a melting point, and it's going to have that waxy consistency and feel in your mouth. And that's not really good from a mouthfeel standpoint. So the solution was chemistry figured out how to do what we call partial hydrogenation. So the idea is don't get rid of all of the double bonds, right? We want some of those kinks. We want some of those kinks to allow for a lowered melting point so that we have that beautiful sort of solid at room temperature, but liquidy in your mouth, right? So we do partial hydrogenation. And that does work. We generate something that has pretty much a similar sort of structure and thus function to saturated fats. Okay. Now here's part of the problem. When we do this partial hydrogenation chemistry, this is how we generate trans fats. So when they talk about this formed artificially, it's through a process called partial hydrogenation. Okay. So, but even if we made some trans fats, it's like, well, you know what? Those are okay, because if we look at what we have here, okay, and compare these two are structurally similar. So structural similarity. Right, and if I pull my models back out, right, and I look at what we'd have here, here again was our polyunsaturated fat, right here was our a cis double bond here. But if I start taking, and I'm going to change the configuration of my double bonds here, it's going to take me a second to just sort of do them. I'm going to move all of those hydrogens. I'm going to show you what I did to this last one. I'm going to move all of these hydrogens here so that they're on the opposite sides. Okay, so I made this double bond now trans. I'm going to go ahead and I'm going to do it for these other two, and then we're going to revisit and sort of see where we're at. Punchline here is that we are going to see that we have something that now really resembles a saturated fat. Okay. So here, if I actually took all of these double bonds and I isomerized them, look at that pretty much looks like I had a saturated fat, right? Trans double bond, trans double bond, trans double bond. Okay, I still have my 3 units of unsaturation, but now it looks and behaves, has the same structure and thus the same function as a saturated fat. Okay, so again, behaves similarly. All right, so here's some of the things that are problematic with that. We will take a deeper dive next semester and we will understand when we learn about the metabolism of fatty acids why having a double bond in the trans configuration can be problematic. Okay, but they highlight here that there are significant concerns with heart disease. So we'll sort of understand that piece. So what sort of happened in the food industry once we started realizing that these were problematic, right? We started doing this partial hydrogenation to take inexpensive plant oils and make them into animal-like fat products. Again, trans fats and hydrogenated vegetable oils behaved like the expensive fat product, but we were deriving them from the inexpensive plant source. Okay, so all of a sudden, and then we started realizing that there were some health implications. All right, so what is the solution to that? Okay, well, we just need to make the consumer aware. One of the things I hope you take after this course is that you recognize that I'm going to get away from looking at the front, the packaging, marketing side of my packaging, right? I'm going to flip my product over, and there's 2 important things I want you to look at on the back side of every food product, right? I want you to look at the ingredients label, and after taking this course, you should be able to look through and read and understand everything that's in your food labels. And I also want you to look at the nutritional facts, that nutrition label, and understand what it means to have all of those different macronutrients there. So just to take a little bit of a deep dive on what you see under the fats component, it used to be that they basically broke fats into 2 categories, saturated fats, unsaturated fats. Okay, again, used to think that saturated fats were not the good ones. I hope to convince you otherwise at the end of this course. But here's the thing, when you talk about unsaturated fats, prior to the advent of this hydrogenation chemistry, these were the only unsaturated fats we had, and they were healthy, they were derived from plants, and so you had these 2 categories of saturated fats that were thought to be unhealthy, and then these plant-derived unsaturated fats. Now, what happened when you started having these trans fats that were there? Well, they're still unsaturated. They still have double bonds, right? So even though they weren't healthy, they could slip into the category on the back of a nutrition label in the healthy category, in the unsaturated fats category. So then there was a requirement that you split out your fats into saturated fats, unsaturated fats, and trans fats. Well, consumers didn't want to have these unhealthy trans fats that were there, right? So they were required to label and put them in there. So now what we see, and again, I hope I've convinced you want to avoid anything with trans fats, okay, is that if there are less than 0.5 grams of trans fats per serving, you essentially are allowed to say that there is 0. So I don't know if you've ever noticed or really paid much attention to the serving size that you have for things, but sometimes you'll have a small package of processed food, right? And it says there's 2.5 servings in there. Well, part of that could be so that when you label things, you can say that there's no trans fats, because as long as you set your serving size so that you can have less than 0.5 grams of trans fats, you're allowed to say 0. Well, here's an important piece. Again, looking at the other important piece that's on the back of a nutrition or a back of a packaged food product, look at the ingredients label. If you see partially hydrogenated vegetable oil, partially hydrogenated vegetable oil, you know that there are trans fats in your product. It's very possible that the serving size is set so that it's less than 0.5 grams and so that they can technically say that it's 0. Okay? But highlighting, in general, we want to avoid trans fats. Now, here's part of the problem, right? We want to avoid anything that there might be an ingredients label or the need for a nutrition label, because that means it's a processed food product, right? If you want to have the best foods possible, you eat things that don't have food labels, and that's because they're whole foods, right? rule of thumb, right, that I often tell my kids is if it doesn't look like how it's found in nature, you probably don't want to eat that much of it. Now, it's not to say that you shouldn't ever have it, but you should try to dominate your meals with food products that don't require a food label. Okay, so a little bit of a story here to kind of pull things together, looking at fatty acids and the different types that we have, how their structure affords function, and importantly, how we can think about where we find these in our food products.